And finally, question 39. I really want to say, hey, you can do this, but you're here. So the fact that you're here and you're watching YouTube math means, maybe you don't know how to do this. So let's talk about it. We do know that if we have two lines that are parallel to each other, right, they have the same slope. So our issue is, as I look at these, none of these equations are written in slope intercept form. So I need to figure out which ones would have the same slope. And as I look at it, it just occurs to me um, there's kind of a shortcut way. They're in standard form. And I'm pretty sure that the answer is going to be A. If you look at A, notice I've got a positive 5 for x and a negative 3y. Here's a positive 5 and a negative 3 for the y. Everything else has different signs and different numbers in different places. If I rewrite, now that I'm pretty sure that that's the answer, let's go ahead and rewrite these in slope-intercept form. So that first equation becomes negative 3y equals negative 5x plus 11. So you can say I added 5x to both sides of this equation. And now I'm going to divide both sides by 3, so I get y is positive 5 thirds x. That's negative 5 divided by negative 3, and then minus 11 thirds. So you can see the slope I'm looking for is 5 thirds, and the only one that's going to have that slope, this one is going to end up being, I think, negative 5 thirds. But the only one that's going to have that is choice A, right? Because I'm going to do the same two things. I'm going to have the negative 3y, and I'm going to subtract 5x from both sides, and I've got a plus 4. And then when I divide by the 3, I've got y is positive 5 thirds x, and then minus 4 thirds. So again, you see the slope. They have different y-intercepts. They're hitting the y-axis at negative 11 thirds and negative 4 thirds. But they have identical slopes, and whenever we have the same exact slope, they have the same rise-run pattern, so they're clearly parallel lines. They're both up 5 over 3. And that's it.